talk about not a new topic, but how to design building. Just a quick reminder for beam. Actually, we have two options or two cases. First one, what is the relationship between your unsupported lengths of compression flange and LP? Sometimes it's smaller, sometimes in between LP and LR. Most of the case. Here we don't have any concern about lateral torsional buckling. Here we have a concern about lateral torsion buckling. So your design bending moment equal phi F yield ZX. By the way, if you use ZX here, your nominal moment here will be nominal moment about X. This point is new a little bit. If you have any cross section like W shape and you have X axis, Y axis, sometimes your moment like this. Go back to mechanics of material. Anybody remember what is the difference between MX and MY? Do you remember? MX is a moment equal force time distance. My is a moment equal force time distance. But if your moment rotate about x-axis, your moment called mx. If your moment rotate about y-axis, it's called my. Anyway, so maybe on your cross section we can have two moments called bi-axial moment. For any reason, like Berger, we will see this. So, if you are using plastic modulus of cross section about x, your nominal or your design moment about x. Maybe your design bending moment about y will be phi F yield Z Y. If you go back to your table for W shape or any shape, you can find properties about x-axis, like I, like S, like Z, like R. You can find section properties about y-axis, like I, like S, like Z, like R. So everything in your table. If you use ZX, your nominal design, your design moment will be about X. If you use ZY, your design moment about Y. Just a quick hint. If you have unsupported lengths in between, I think you will have another design bending moment using CB time phi MB, I think, minus phi BF LB minus LP, as I remember. So, even for this equation, every part you can get it from your table based on what is your cross-section need.
Are the values for like the x-axis and the y-axis the same one, or do we only?
No, not the same. Different value based on what is the value of Zx, because Zx will not equal Zy because your cross section not identical about x or about y.
Right, but on this side of the whenever the.
For this one,
Yes.
Yes. This one, if you go back to your table, phi m plastic about x. We have another phi m plastic about y. If you don't have this value ready in your table, go ahead and use the m plastic equal f yield times z. If you would like to get m plastic x, zx. If you would like to get m plastic y, use zy. Okay? Anyway, just quick reminder also, and I believe you covered all of this stuff during mechanics of material. Your mx, your force, and your distance, one of them in y direction and the other one in z direction. If you would like to get my, one of them any moment, force time distance. If your force and your distance, one of them in y direction and the other one in z direction, the product equal moment about x. If your force or your distance, one of them about in x direction and the other one in z direction, the product equal moment about y. Why you are talking about this stuff here? Go ahead and remember. For Berlin, Berlin is a beam between your main system. We have here something called main system. Maybe your main system is truss or frame. If your main system is truss, I think location of your Berlin, where?
At joints.
At the joints. Perfect. If you have main system like frame, you have a specific distance, equal distance. You can choose something around 5 feet, 10 feet, or something around this. Anyway, your Berlin is a beam, simply supported beam between this main system and the following main system. What is the load on this beam or on this Berlin? What do you think? First, on weight. This Berlin has weight per unit length. You can assume your own weight of Berlin, which is called WG, something in between, because right now I don't know what is the exact cross section. So I can assume it 120 to 150 pounds for each unit feet. Second load, I'm talking about dead load. Second load, what do you think about the additional load? What do you think? Yes, corrugated sheet. Maybe concrete slab. So we have weight of covering material, WC. Maybe your covering material or your roof is flexible roof or corrugated steel sheet. You can assume something in between 25 to 50 pounds for a square feet. Or you have concrete slab, then your WC per unit area equal gamma TS. Anybody remember what is the value of TS?
Thickness.
Thickness of your slab. And gamma for concrete. This value must be written in your mind. From concrete, gamma for concrete equal 150 pounds per cubic feet. If you multiply both of them, you can get a value for WC. Or if your roof is corrugated steel sheet, you can assume something in between. Remember, for weight of covering, your unit bound for square area. For area. So each Berlin will support covering load from center line to center line. So the area served by this Berlin equal to this one. And this load inclined projection. So anybody remember what is the value for this distance? Called A prime. So your Berlin as a simply supported beam has uniform distributed load, W, dead load equal WG on weight of your Berlin plus WC weight of your covering material per unit area time A prime to convert it to distributed load over the building. So first step, we would like to calculate the dead load on your Berlin. We have two kind of dead load. First, on weight. I don't know what is the exact cross section, so I will assume my own weight, something in between 100, 120 until 150 pounds per unit length, which is the unit for W. The second one, you're covering, if you have corrugated steel sheet, assume something in between. If you have concrete slab, get your value by gamma, by multiply gamma times TS. Then your W dead load equal your own weight plus your covering weight time A prime. Why A prime, not A? Because your covering material is inclined projection. Any question so far? I think all this stuff not new information. We covered all this stuff before.
I do have a quick question.
Yeah?
So at the end, for the square area, it's going to be divided by half,
Yes.
and then at the top.
Most of the time we are designing the worst case.
Okay.
It's okay, you can use this cross section like this one, more safe. If you need more economic, no, this cross section must be half this value. Okay? Second, load, your life load. All of this stuff covered before. If you're inclined roof with angle equal 10 degree or less, also if your roof is axis or not axis, based on all of these parameters, I can figure out what is the value of life load. 30 pound per square feet, 15 pound per square feet, or your slope of the roof greater than 10, so your life load equal 15 minus 0.5 times each degree over than 10 degree. So once you get your life load value as pound per unit area, multiply this value by A. Why A? Because your life load is horizontal projection. So we need the horizontal distance between Berlin, not the inclined distance. Once you multiply your selected value of life load by A, you can get W life load. So right now, after calculating life load, we have a simply supported beam with uniform distributed load, W life load. Step before, we calculated W dead load. What's next? We have life load. We have wind load, but we will neglect wind load. Anybody know why we need to neglect, or why it's more safe, or it's okay to neglect wind load? Why? Because wind load is more complicated. That's right.
Yeah.
Yes, embrace.
Why?
You won't really have wind blowing down straight down.
Yeah. Your dead load coming down, your life load coming down, your wind load is suction. Will decrease the effect of dead load and the life load. So finally, if you take wind load and the life load and the dead load at the same time, your final distributed load on your Berlin will be very, very small. However, in many cases, we don't have wind. Right now, we don't have wind on the building. The only effect is dead load and life load. So the best scenario to design your Berlin only dead load and life load. Why? Because wind load cause suction, which will decrease the effect of dead load and life load. However, wind load not all the time on the building. So the worst case to neglect life load, because life load will relieve the weight or the load on the bearing. So this load can be neglected in design because it has a suction effect. Go ahead.
But wouldn't we also factor that in the main load?
In what?
When doing the main load, the main system?
For bracing, for truss,
Yeah.
sometimes this effect will cause, because you have complicated structure, many members. So I cannot say, hey, this effect will release the effect of dead load and life load. It's not easy. Also, I did more combination. I didn't only say dead load plus life load plus wind load. No, I did, I think 6 or 5 combination. And Riza told me what is the maximum effect.
Okay.
Here, I don't need to do this because I know if I add wind load, your combination will be less. But if you didn't add wind load, your effect will be the maximum. 1.2 dead load plus 1.6 life load. So this one is very simple example. I can say, hey, wind load will not give me maximum effect. Sure, about this point. Anyway, okay, all of this stuff is very easy and I think no problem until now. The main issue is, you agree that your Berlin, whatever channel or Z section or W shape, I don't care. Your Berlin is supported by your main system. And your main system at this location is inclined bar with angle theta. That's right? So your Berlin will have inclined angle with the vertical direction equal theta. What's the problem? The problem is your dead load, your life load is a vertical load. What is the problem? The main issue that your load is not in the direction of x-axis or y-axis of your cross-section. Something in between. It's not good. It's not good.